Hey everyone. Tonight's video is about what we call the parent functions. And these are the most basic graphs of different types of functions. Okay, so the first function you find on your sheet is f of x equals x. And this is a linear function. The graph is actually a line that goes through the origin and has a slope of 1. And if we analyze that graph, the x-intercept, which remember that's where the graph crosses the x-axis, is 0 because it goes through the origin. The y-intercept is 0. The domain would be all real numbers, or negative infinity to infinity. The range is also all real numbers, or negative infinity to infinity. If you notice, if you look at this graph from left to right, it's rising, so it is increasing from negative infinity to infinity, and it does not decrease. And remember that even and odd has to do with the symmetry of the graph. So this is actually an odd function because it is symmetric with respect to the origin, which again means if we rotate the graph 180 degrees, we end up with the same graph. All right, so that again is a linear function. Again, this is like the most basic shape of a linear function. All right, let's go to number 2. Okay, f of x equals x squared. This is a quadratic function. And the graph is a parabola. And again, we're just kind of like quickly sketching the overall sketch of the graph. So this is a parabola that opens up. And so again, if we analyze it or find the characteristics, it goes through the origin. So the x-intercept is 0, the y-intercept is 0. The domain, if we, again, read it from left to right, we have arrows on the ends. So the domain is all real numbers. And the range, if you read the graph from the bottom to the top, our y values actually start at 0. So the range would be 0 to infinity. Now, this particular graph, again, if you look at it left to right, is decreasing from negative infinity to 0, and then it's increasing from 0 to infinity. And this is actually an example of an even function, which again has to do with the symmetry of the graph. An even function is symmetric with respect to the y-axis, so basically that just means it's the same on either side of y. Or if we were to reflect this half of the graph over the y-axis, we would get this half of the graph. Okay? Now, on your worksheet, I'm kind of drawing a bit more than what you need to draw. On your worksheet, I just want you to have that basic shape of the graph. Okay? So again, here's our parabola. Okay, moving on. All right, number 3. This function is x cubed, so we call this a cubic function. And the graph actually looks like this. And so the x, again, it goes through the origin, so the x-intercept is 0, the y-intercept is 0. The domain here is all real numbers, or negative infinity to infinity. Same with the range. And this particular function, again, if you look at it from left to right, is increasing from negative infinity to infinity. It does not decrease. And this is actually an odd function. Again, it's symmetric with respect to the origin, or if we rotate it 180 degrees, we would get the same graph. All right, let's look at number 4. This is square root of x. So we would call this the square root function. And its graph looks like this. And so it does actually go through the origin, or the origin is a point on the graph. So the x-intercept is 0, the y-intercept is 0. Now the domain this time, if you read the graph from left to right, your x values start at 0 and then continue to infinity. The same thing happens with the range or the y values. If you look at the graph from the bottom to the top, the y values start at 0 and continue to infinity. This graph is increasing because it's rising from left to right. And so we would say it's increasing from 0 to infinity. It does not decrease. And this one is actually neither even nor odd. So we'll just put neither. All right, let's look at number 5. All right, this is 1 divided by x. This is called a rational function. All right, so the rational function has an interesting graph. It actually looks, ooh, that's kind of bad. I'm going to fix that. All right, it actually looks like this. That's better. Okay. Now, this one is kind of interesting because the graph actually does not touch or cross either axis. So there is no x-intercept, there is no y-intercept. And because of that, for the domain, we would say x cannot equal 0. Now, you could either look at the graph and notice that there's a break at 0. It's actually a vertical asymptote, which we will talk about in more detail later. Or you could just look at the function itself, and remember we learned if the function has a fraction bar with a variable in the denominator, then we know that denominator cannot equal 0. So you could look at it either way. Now the same thing actually happens with the range. Y cannot equal 0. This time we actually have a horizontal asymptote there. Okay, now if you look at this graph, and again we're going to read it from left to right, it's actually decreasing from negative infinity to 0. And then that's basically looking at this part of the graph. But then over here it is also decreasing, but we have to write a separate interval because 0 is not included in that, okay? So it's decreasing from negative infinity to 0 and then decreasing from 0 to infinity. And again, this one does not increase. And this is actually an odd function because it is symmetric with respect to the origin. If we were to rotate it 180 degrees, we would get the same graph. Okay, number 6. This is the absolute value function. You might recognize the absolute value symbol. So its graph actually looks like a V. It's actually, what's happening is, it's like graphing your linear function, but where we get negative y values, the absolute value is going to make those positive, so it basically just like flips that part of the graph up. And you get your absolute value function. Okay, let's go back. Okay, so this is absolute value. And again, it goes through the origin. So the x-intercept is 0. The y-intercept is 0. The domain, if we look at the graph, left side and right side, we have arrows on each end. So the domain is negative infinity to infinity. And then for the range, if we look at the graph from the bottom to the top, our y values actually start at 0 and then continue to infinity. Now, again, for increasing and decreasing, if we read it left to right, this function is decreasing from negative infinity to 0 and then increasing from 0 to infinity. And this is actually an even function. It's symmetric with respect to the y-axis. Okay, now number 7. This is a cubed root function. We have the cubed root of x, so we would just call this a cubed root. Okay, so its graph is kind of interesting. It looks like this. All right, so again, it goes through the origin, which you're probably noticing a lot of these parent functions, their graphs go through the origin. So the x-intercept is 0, the y-intercept is 0. The domain, if we look again left to right, we have arrows, so the domain is negative infinity to infinity. The same thing would happen for the range. If we look at it from bottom to top, we still have arrows on either end. And if you notice, again, read it from left to right, this function is increasing always. So from negative infinity to infinity, it does not decrease. And this is also an odd function. If we were to rotate it 180 degrees, we would get the same graph. All right, number 8. This is a logarithmic function. And the logarithmic function actually goes through the point 1, 0, and it looks like this. Okay, so this particular graph does not go through the origin, but because it goes through that point 1, 0, the x-intercept is 1. This graph actually does not have a y-intercept because in this case the y-axis is a vertical asymptote. So at this end the graph is going to continue to get closer and closer to the y-axis without actually touching or crossing it. Okay, so if we look at the domain again, for your x values we would say that the domain is 0 to infinity. But we don't want to put a bracket on 0 because 0 is not included in the domain. And then our range here is all real numbers. Because again, if you look at the graph from bottom to top, we have arrows on each end. Okay, this particular function is increasing, again, from 0 to infinity. It does not decrease. And this one is neither even nor odd. All right, and then our last parent function is e to the x. This is called an exponential function. And its graph actually goes through the point 0, 1. And it looks like this. Okay, so again, this graph does not have an x-intercept, but it has a y-intercept of 1. And the domain for this one is all real numbers. And the range, if you notice that the graph is above the x-axis, so our y values are from 0 to infinity, but not including 0. This particular graph has a horizontal asymptote, which is the x-axis. And so what's happening at this end is it's getting closer and closer to the x-axis without touching or crossing it. And then this graph is always increasing. So from negative infinity to infinity, it does not decrease. And this one is also neither even nor odd. Okay, so these are your 9 parent functions. You need to study them. What you need to be able to do tomorrow is, if I give you the function as an equation, okay, let's say I give you this, f of x equals absolute value of x, I want you to be able to very quickly sketch that graph and know what it looks like. Okay, that one is the v. Or if I give you a graph, I want you to be able to tell me what the function is. Okay, so if I gave you this graph, you need to be able to say, oh, okay, that's the quadratic. That's f of x equals x squared. Okay, because where we're headed with this next is we're going to be graphing these functions. So we're going to graph them by starting with the parent graph and then transforming it. So we're going to talk about things like shifting the graph up and down, left or right, or stretching it, compressing it. So it's important that you know your parent functions and what their graphs look like. All right, I'll see you tomorrow in class.